Okay, great. So first of all, I would like to thank the LoRaWAN Alliance to organize this event. This is really great to be here, especially after this long COVID period. So it's good to be here, and really thank you also to join this session. So my name is Anicet Giaimo. I am working with STMicroelectronics, and I am in charge of our wireless system-on-chip product, the STM32WL. So today we will deal with some top stories behind LoRaWAN, and we will see how the STM32WL ecosystem has been useful for such success stories. Okay. So IoT applications are everywhere, and we have IoT applications around us that we even cannot imagine. For instance, for the remote monitoring of meters, or again, for the control of farming, or for the environment sensing in cities or in forests, for instance. So now, to cover this kind of application, we need some wireless solution. And such wireless device has to be flexible, it has to be worldwide capable, it has to support a robust RF link in order to provide quality of service, and it has to be ultra low power in order to provide extended battery life to make sure that the mobility is guaranteed. And on top of the great product comes a great ecosystem. And here in ST, we are providing a full set of materials, both on hardware and on software. So for that, we have a solution that we call the STM32WL. So what is this product? What is the STM32WL? Here it is. So this is actually the integration of one low-power microcontroller plus a multi-modulation radio supporting LoRaWAN modulation, of course, plus FSK, MSK, and BPSK. And on top of that, there is a Cortex M0 core to provide with security features. And all of that has been integrated in a single core, in the single die product that we call the STM32WL. And by the way, the WL is standing for wireless long range. But actually, in ST, we didn't stop here. Since we launched this product, we have extended its ecosystem to bring to our customers simplicity, again, more integration, and an easy-to-use solution, flexible solution. So to have a complete view of our ecosystem, let's go back to the history. Let's go back to the time that we launched this world's first LoRa-enabled SoC, the STM32WL, by the end of 2019. After that, 2020, we have released a dual-core version of the product that brings even more integration to our customers by having, for instance, the application running on one core and the wireless stack running on the other core. We have also released a QFN48 package to bring simplicity on the hardware design and in order to allow our customers to design simple PCB to manufacture. Thanks to that, we have won the IoT World Award in 2020. 2021, where our users get access to even more flexible cut of the STM32WL that allows to have long packet support. Such release enable our partners, our customers, to have multiple protocols running on the same product on the STM32WL. Then we have also the LoRaWAN 1.0.4 stack on our website that is available for download. And we have certified our evaluation board that allows fast prototype, the STM32WL Nucleo board with this standard. And here we go. Here we come with 2022. With the last release in our ecosystem, our reference designs. And here I will detail later what we provide with this reference design and how we can simplify the RF designs. Then later this year, we will release the LR-FHSS support, this new modulation, by November this year. And we will update our firmware package because the product itself supports it, and we will update our firmware package to have the capability to support this modulation. And this is quite important, especially to prepare the future of IoT, because IoT is getting massive and massive. So having such kind of modulation can allow to support dense network. and also to have satellite connectivity. So this is the journey of the STM32WL ecosystem. Now I would like just to focus on the reference design. I think all of us have heard already that RF design is complex, RF design is time-consuming, difficult task. Well, yes, this was the case before we released this reference design. But now you have access to a free set of schematics, layout, bill of material to help you to design your RF side. And that really can be useful to reduce the time to market, because it is FCC and CE compliant, and it's an open hardware that you can reuse in your own design. It is optimized to get the best performance from the RF, and the power supply circuits, the RF matching circuits, RF filtering, and all the passive components are integrated, and that you can reuse it. So now, no excuse to start your LoRaWAN based application, as we have this reference design available. You have not only access to one reference design, but it's actually a set of reference design here that I'm talking about. And each of these reference design has been tuned for each country regulation. So it's, for instance, from the low band for China market, for instance, to the high band, the European market or US market, as you can see. And also it is available for the two different packages of the WL, the BGA package that allows to have a really small form factor, just 5x5 package size, in order to reduce drastically really the size of the end product, and the QFN48 package in order to make a simple solution, in order to make a simple PCB solution. Reference design are not only a way to save time, it's also a way to get access to some innovative features to reduce your BOM costs. For instance, with this two-layer PCB design, you can reduce the cost of the PCB thanks to that. And here again, this has been fine-tuned for each country regulation, available in 3 different versions. A second way to reduce the BOM cost is to save the cost of switch in the BOM. So here we have a direct tie design that allows to actually tie together the RX and the TX signals are tied together, and that avoid to have an RX and TX switch on the BOM cost. Okay, great. So this was for our last ecosystem release, the reference designs. Now I would like to switch to some concrete use cases and to see how our customers use the STM32WL in some end products. And here we have one smart meter product made by our customer IoT. This is based on the STM32WL55. So IoT is one of the largest system integrator in Europe. They are a global company with the headquarters in Poland, and they have projects and competence centers all around the world. Here we can see their smart metering application, which is called Apples. So this is actually a kind of radio module that can be put on an existing meter, on a mechanical meter, for instance, to add a wireless connectivity to a meter that do not have it natively. So this is really convenient, as it can be used on a working meter, and it can be simply installed on a working meter to add the wireless connectivity. And this has really 2 main benefits. First, the long battery life that can go up to 10 years on a single battery, and the robustness as well, as it has been designed to be used in external conditions. So here I'd like to describe how the STM32WL can be useful on the low power aspect and on the robustness aspect. On the low power side, so IoT got access to our ultra low power platform, and this can help really to provide a flexible power scheme in order to tailor and to really fine tune and find the right trade-off between a fast wake up time, between the peripheral that can be used in low power mode, the retention on the RAM, and the RF state. And this helps really to optimize, to find the right trade-off, and to get 10 years battery life, for instance. We have some specific features here. On the peripheral side, for instance, we are able to have the peripheral working without the use of the CPU. And this is achieved thanks to a batch acquisition mode. And here the peripheral has a direct access to the memory. And for sensing application, this is really great, for instance. On the RAM retention, we are able in this way to keep the application context. So such a way that the application can resume once it once it's leaving the low power mode, it can resume and keep the same state as it was before going to sleep. The RF is available in all low power mode, means that even down to the lowest power consumption, you can have the RF working. Well, now let's talk about robustness. And when we talk about robustness, I like to talk about it is about safety and about security. And here, customer and user has a way to protect their data from corruption, for instance, with memory integrity features like CRC, like a parity check on the RAM and on the flash. And also to stabilize, to make sure that the clock and the supply is stable, we come with features like clock security system and brownout resets. Also to monitor the well execution of the code with dual watchdog. On the security side here, this is quite useful in meters application because we have capability to detect and to protect from a physical attack with the anti-intrusion features, for instance, that has a tamper detection. And in this way, we can detect if someone is trying to open the meter, and we can make the action based on that. We have also data encryption hardware secure engine that allows to encrypt the data in a really efficient way, and the root of trust capability. And now just a word on the ecosystem, how it can be useful to develop an application, starting from the really beginning of the project, starting from the configuration of the project by using our graphic user interface, the STM32WL, for instance, that allows really to configure the application and to generate the initialization code. Then it comes also to the compiling stage and the IDE that we provide with ST and with our partners. And at the end, for the validation of the final application, we come with programming tools and monitoring tools. Okay, great. So we have seen how the WL can be useful for metering application. And now I would like to move to a different application, a different use case, a use case that can be useful to everyone in this planet, a use case that can really protect our ecosystem. And here I'm not talking anymore about the software ecosystem or the hardware ecosystem. I'm talking about our planet ecosystem. I'm talking about our environment. And I think you know, some of you, this application is made by Dryad. And this is a way to protect our forests from wildfires. So what is really important here, especially during the summertime, is really to protect from fires. And the place I come from the south of France, we have fires that happen every year. And especially with the strong wind that we have in south of France called Le Mistral, the fire spreads really fast. So here Dryad has a really smart solution that allow early detection of wildfires. So for the one that didn't attend the session before, so actually they have sensors located across the forest that helps to detect the fires without false detection. And then it reported to the cloud thanks to a LoRaWAN plus a Dryad proprietary mesh network. And on the sensor side, so this is based on the STM32WL. And this has been also designed in a way to protect the environment as it is battery-less, as it is using energy harvesting, using solar powered. And on that side, the WL provides a really efficient way to control the power consumption. So I would like to show you now another way to optimize the power consumption thanks to the WL that is really useful in such kind of application. This is actually our flexible power implementation. Because in this product, we are providing the flexibility for the user to use an LDO or to use a DC-DC. And here the DC-DC provides a really efficient way to control the power supply that I will really show you the evidence later on our power figures. You will see really the benefit of the DC-DC. The second point is something that makes the STM32WL a unique product in the market, as it comes with a dual power amplifier, with one power amplifier optimized for the low power that can go up to 15 dBm, and these provide really outstanding power consumption that I will show again later in our power consumption figures. And the high power consumption, high power amplifier that can reach really long range and that can go up to 22 dBm. And this actually provides two main advantages. One of it is to be worldwide capable. On the same device, we are able to cover the full country regulation over the world. The second point, of course, is about the power consumption, as I said. And here you see the evidence of having a DC-DC in such kind of application. You see that with a DC-DC, it can go down to 4.82 milliamp in reception mode with LoRa modulation. So you can see the differences between a DC-DC and an LDO on this slide. On the transmission side, from here we can see the advantage to have the dual power amplifier, as we can see that at plus 10 dBm, so using the low power amplifier, we are going down to 15 milliamp in transmission mode. Okay, that was for the low power aspect, and just to go to the ecosystem side and how it can be useful to design an application such as the one of Dryad. Starting on the beginning, really on the beginning of the project, with at the learning stage, I mean, of our customers, we are providing with online trainings. We have a full set of application notes, and recently we have released some wiki page that allows to get started with LoRaWAN application. On the software side, as it has been used by Dryad, we are providing a LoRaWAN stack that is available on our CubeWL package online. On the hardware, to provide a fast prototype, we have this evaluation board that can be used on the beginning of the project as well. And as I described before, the full suite of tool sets that allows really to develop the application. Okay, so we have seen that on this really amazing application to protect our environment. One other point I would like to highlight to you is about modules that can really help you with reusing such module to design really fast your application, to reduce your time to market, to provide simplicity, as with just one single product that will integrate the full BOM cost, you can create a wireless application, and integration, as modules come with really small form factors. Here we have more than 18 modules based on STM32WL. And so you can select the one that fits your needs based on the form factor, for instance, or the country regulation that you want to achieve. Okay, we are talking here about flash-based microcontroller. So we are talking about a microcontroller that can be programmed. So FIOTA, firmware update over the air, is quite important in this topic, as it can allow really to have firmware update on the field when the application is already deployed on the field. It can update it in a wireless way. And here I would like just to invite you to have a look to Activity booth at 3 p.m. on their booth number 32, to have a look to a demonstration based on their network server and using STM32WL library also to update a fleet and to create a FIOTA campaign of STM32WL fleet. Okay, so now, and also, of course, last but not least, I would like to invite you to come to our booth, to meet with our experts, to have a look to our demonstrations. We have a great demo there, a demo showing asset tracking application that combines LoRaWAN and BLE. And we have also a demonstration showing smart metering using AI to read the meter counter value and report it to LoRaWAN. Okay, thank you for listening. If you have any questions, please let me know. And again, welcome to see us on our booth and welcome to see Activity for the FIOTA campaign that will be at 3 p.m. Thank you.
I've got a quick question.
Sure.
Just on, if we could zoom out a little bit from an STMicro point of view, how you see this market now and the shift, in LoRaWAN in terms of volumes. You mentioned kind of massive IoT.
Yeah, right.
This
yes.
is what we're all grasping at. These kind of, hardware designs, silicon design is clearly important to that. I just wonder how you see it now, where we're at now, and how much complexity of radio design, this kind of stuff, has been an issue for this market today.
Well, radio design has been, there's been an issue. I mean, for some people that are not familiar with RF design, in order to really democratize and to have something more easy to develop, so solutions are there, like modules, as I said. We provide reference design, and this really to extend the market capability and to allow customers that do not have the RF capability, the RF engineers, to be able to start an IoT application, to make sure that IoT can be used in some application that originally was not wireless made, but that can be wireless, like we have seen also from IoT. A meter that is not wireless made originally can be easily, with an external module, can be easily connected. This is an example of a growing market, a growing IoT market that can be also interesting. On IoT sensors as well. On IoT sensor, we see more and more for smart buildings, for environmental sensing as well. It's growing up. It's growing up, and here LoRaWAN provide an interesting solution by having a way to make some proprietary network, a way to have something more simple also to make in use, to create and to deploy on the field.
I mean, IoT has been making meters for a long time, right? It knows this very well. So in terms of radio design, presumably the message you're saying is that this new product line kind of simplifies things for new people to an extent coming into the market, solution developers, this kind of stuff. It's also more performant. It's longer battery life. It's presumably there's a cost impact as well.
Yes, exactly. It has a cost, but it has a value. It has a big value because thanks to the low power aspect, so it's enabled some, as we've seen, some energy harvesting solution. It enabled also to have long battery life, so without the need of replacing the battery, can be also used. The fact to reduce the power consumption can be a way to reduce the form factor of an end application, and in such a way that it can be deployed again in some area that even we cannot imagine today. And yes, this is actually our goal is to simplify the RF design in order to make sure that our customer, and especially the customer that do not have the RF expertise, to make sure that they are able to start on that. Yeah. Sure.
So I just want to confirm that we are a software company, no radio experience at all. We took the schematics from STM and put it in our own product, and it's up and running.
Okay.
And one thing, maybe I do some advertising for STM.
Yeah,
now,
I didn't pay him.
No, I'm not paid, and I don't have any shares. But actually, STM has a lab in Prague, and they did an outstanding job. So we had a problem with our first version. There was a problem of the PCB manufacturer, blind via, that was missing, and they found out, and they gave us a free consulting that was very valuable. So you can do it without radio expense.
And do you feel now that the whole IoT game is opened up for you?
It's a new world. We are actually doing software with apps and servers, and we needed the last mile, the connection. We needed a device, and we did that way. And the reason was because it was one process that had everything. So it's working. It's really working.
I can't believe it.
Well, no, I'm not paid.
Thank you.
Okay.
Yeah. Thanks for your attention.